Okay, here's the experiment which debunks the greenhouse effect. Greenhouse effect of carbon dioxide. Debunks carbon dioxide as a greenhouse gas. We've all been told many times that carbon dioxide is a greenhouse gas which traps heat and causes global warming. So can we test that? Yes, we can test that very easily. This experiment has cost me so far less than £5. These little thermometers, the fish tank thermometers from a tropical fish supply shop, cost about £1.50 each, and of course a bottle of mineral water, sparkling mineral water, carbonated with carbonic acid, costing about 50p to buy. So there you have it. AGW, anthropogenic global warming, carbon dioxide greenhouse gas theory debunked for £5, less than £5. So this experiment will set out to do that. Okay, so we've got 3 empty plastic bottles. One is dry, a dry bottle containing nothing but air. That one will stay as it is. But firstly, I will just make sure the lid is tight. Make sure that lid is done up very tight. And I'll just write on the label here, dry air. Okay, we can read that, can't we? We can read that one, dry air. So, you can see how sensitive the thermometer is, because just by holding that bottle for a couple of seconds, the warmth from my hands has increased the temperature by 4 degrees from 18 to 22, and now you can see it falling back slowly. That's how sensitive these thermometers are. They're for this purpose excellent little devices. And what we're going to do is we're going to take the temperature in each bottle up above 30 degrees, the uppermost reading on the thermometer, and what we're going to do is monitor the temperature as it falls to see which container retains most heat. This is an undeniable experiment and will show whether CO2 is more efficient at holding on to heat than just ordinary air. Now, in the CO2 bottle, we're going to half fill this bottle with carbonated water, and then we're going to shake it up. And as the CO2 is supposedly heavier than air, which it is when it's at low temperature, it's heavier than air. So the CO2, the pressure of the CO2 will compress any air that's left in the bottle up to the top, and then we will release the bottle top and allow that air out. So what we end up with is a cavity of pretty much pure CO2, which is way and above what we will have in the atmosphere. So what we'll be testing is pure CO2's ability to trap heat, to hold on to heat, and we will test that by squashing out any other air, and in here we will just have a pressured container of CO2. So just because of what I've just explained, I'm going to write pure CO2 and water. There, can we read that? So, yep, pure CO2 and water. And in the middle bottle, I'm just going to put ordinary tap water, halfway, the same level as the carbonated water, and just ordinary air. So tap, can we read that? You have to excuse my handwriting, it's not the best in the world, but it will do. Tap, water and air. So the control is the empty bottle of dry air. That gives us our control, because we've got the dry air, we've got the water and air, and then we've got the water and CO2. So we've got a cross control there, which shows that we can't say, oh well, it's the water, you know, it's because of the water, or it's because of this, because of that. That's why I'm using 3 bottles, so that we get a fair experiment and people can't pull me up on anything here. So really, this should be a defining moment in the AGW debate. So there you go. And let's just let those thermometers just all try and equalize a little bit. Well, let's put the water in first. So we'll put some tap water in the middle bowl. Half full. Let's just, so you can see it's ordinary tap water. It's going in there. Okay, I might just want to put a little bit more in there. Lucy, could you fetch me a little bit more tap water, please? Okay. I'll send my assistant off to the kitchen sink. And just pull back here. As you can see, all the thermometers are around about equal. Thank you. I just want to top that bottle up so we're sort of about half full. There we go, some fresh tap water. About halfway. There. Now, what I'm going to do is I'm going to decant some of this sparkling water into the jug and then pour it into the CO2 bottle. There you go, you can see that is very fizzy, very carbonated, and that will pressurize the CO2 bottle and force out any air that we don't want in there, giving us cavity of pretty much pure CO2, which is essential for this experiment. So we can get a good look at what CO2 actually, how CO2 actually responds to heat, and test what they have been saying about CO2. And what they are saying about CO2 is that it traps in heat, and we're going to put that to the test right now. As you can see, this water is very carbonated, lots of carbon bubbles in there, very carbonated. Already, I would imagine most of the air has been displaced by carbon dioxide. Remember, the carbon dioxide is heavy, slightly heavier than air when it's cool, and this is quite cool. Not when it's warm, of course. It quickly expands and very quickly rises under convection, and actually acts as a temperature regulating gas, but we're not going to go into that just now, because there'll be plenty of people who'll be screaming, "Liar, liar!" But it's true. Anyway, so there you go. That's almost the same level as the tap water, and it's clearly very, very carbonated. And what I'm going to do is I'm going to put these two lids on, nice and tight. That's the wrong lid there. That lid on there. Now, where's my other? I've lost a lid here. Oh no, that's it. I've got this lid here. Wrong lid on there. So that lid goes on there, and I'm going to tighten the lids up very tight, especially the water, so that no air can escape when it gets warmed. And I'm just going to shake this bottle just to get the last bit of air out, if there is any. There will be a little. Oops. Now you can hear that. You can hear that sort of the pressure. Let's have a listen. Now that should have squeezed out every last drop of air, and now we've got a very tight, compressed, high pressure container of CO2. And I'm sure no one would be able to disagree with that. That's what that is. So we have one tight as a drum container. You can't pinch it like this one. See? That's high pressure CO2, 100%, almost 100% pure CO2 with water. Here we have tap water, ordinary air, and tap water. This is just dry air. That's the control. That bottle is the control. Okay, so what we're going to do now, and I'm going to do this very quickly, get it underway, is I'm going to turn on the heat behind, and we can see that all the thermometers are equalizing nicely. The temperature here is quite obviously equalizing. Each bottle reading the same. What's going to happen when I turn on the heat, the temperature is going to go up over the top of the thermometer reading. It's going to go beyond 30. The air in each bottle is going to very quickly absorb a lot of heat. It does this very quickly. Air absorbs heat very, very quickly indeed. It's a very powerful absorber of heat. So, and you'll see how quickly these thermometers rise. You probably won't see because of the light coming from behind on the heater. You're not going to see the temperature going up. But when we turn the heater off, what we're going to do is we're going to watch the temperature drop. And as we watch the temperature drop, we will know which container is retaining heat, which gas, the air, the dry air, the tap water air with a little bit of humidity, and the pure carbon dioxide and water. You know, we will see which one, which retains more heat. And this experiment will be the defining moment in the AGW debate. And here we go. Okay, temperature rising very quickly, much quicker in the tap water and the ordinary dry air. CO2 is lagging behind, it's much slower to absorb the heat. The tap water and the dry air are already at 30. CO2 just coming up to 28 to 30 now. Okay, the other two have already absorbed all the heat they can. I'm just waiting for the CO2 to catch up. The CO2 is much slower. It's just got there now. Okay, let's just leave it a couple more seconds just to make sure they absorb enough heat. And now what we're going to do is we're going to watch as the temperature drops. Oops, excuse me. And we will see, and I'll zoom in. I'm going to zoom into the tap water. There. You can see the CO2 is already dropping to 30 degrees. CO2 is losing heat faster than the tap water. There you go. The camera's not lying. CO2 is already losing its heat. Already. It's already dropping. Now, I've got a bit of a... Look at that. CO2 is already at 28 degrees. The tap water and the dry air haven't... Well, dry air is just starting at 30. You can see there the colour of the dry air is just beginning, 30. Tap water, just beginning, 30. Where's CO2? CO2 is already at 26. That's pure CO2, 26 to 24 degrees already. Tap water, still 28. Dry air, 28. There you go. Dry air and tap water are even Stevens. The CO2 at 24, 22. 24, 22, CO2. You can't make this up. This experiment is infallible. I've done it over and over again. It does not fail. It does not fail. There is no other explanation other than the fact that CO2 is not a greenhouse gas. It is not a greenhouse gas. 22 degrees and the tap water and air is 24. The dry air is 24 and the CO2 is already pushing 22. 20 degrees. It's falling to 20 degrees already. You can see, it's quite clear that the CO2 does not trap heat. Those two are even. Those two are even. There's no denying it. There you have it. Look at them. The camera doesn't lie. Look at that. 20 degrees already. Consistently less efficient at retaining heat. Pure CO2. Consistently less efficient at retaining heat. Unbelievable. There you go. That's tap water and air against pure CO2 and water. Pure CO2. A child could perform this and debunk AGW. Dry air and tap water even. pretty much spot on together, dead even. And there you go, pure CO2. Almost down. Now I'm going to run this one more time so that we can be sure. I'm going to run this experiment one more time so we can see that I haven't done anything to cause any bias. As I said, a child can verify this experiment and debunk the biggest lie, the biggest scientific fraud in the history of humanity. Can be debunked quite simply by a £5 experiment. Okay, all those are pretty much at the same level again, and I'm just going to pan back. I'm just going to zoom out, and I'm going to turn on that heat again, and we're going to watch them at this distance all together. I'll just zoom in a touch so we've got them all together, and you can watch them all together. I'm not going to do anything. I'm just going to turn them on. I'm going to watch the heat go up, 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 up it goes, up it goes. The tap water is going high, high, 26. And the CO2 is the slowest, just coming 26, while tap water is 28.30. CO2 is just coming in 28.30. So it's also, not only is it slower to absorb, which is, this proves the Stefan Boltzmann law. The faster rate that this emits is inversely proportional to the slower rate that it absorbs. So that's why that one always lags these two. The pure CO2 absorption rate and temperature increase always lags behind the tap water and the dry air. So it verifies the experiment in both directions, and I'm just going to leave that now, and you can watch those temperatures fall for yourselves. And this experiment is well, it's just proof that AGW is a fraud, I'm afraid. It proves it. Pure CO2. Anyone can do this test and you'll get exactly the same results as I do. It's a simple test. It couldn't be easier to debunk AGW for £5. Just going to get myself a little drink of mineral water because I'm a little bit thirsty. A nice bubbling, carbonated. Lovely. Cheers. Down with AGW. I'll drink to that. Now let's just see. We've got, there you go. There's no denying that CO2 here is falling faster. It's re-emitting its heat much faster than the other two, dry air and tap water. There. That's it. AGW debunked. £5. CO2 clearly does not trap heat, not even when it's pure. The CO2 in our atmosphere is 0.03811%, not 100% or 99 or 98% or even 90%. CO2 is 0.03811% of the atmosphere. So even at 100%, it retains less heat than tap water and dry air, or just dry air. Undeniable.